Hello and good morning, and thank you so much for joining me here. It's June 11th, and this is a quite a challenging radio I've got in front of me here. So I think there's still a few more things I can attempt to understand before starting to make changes to the radio or work on it in any way. One of those is to simply take a look at how the heaters are powered. Now we could assume in this radio they're all 6 volts, they're all in parallel, and all it would be to change them from the 2 volt system that they were running on. Where did the 2 volts come from? Oh, batteries. What am I thinking, for crying out? Right. This thing got all its supply voltages from batteries originally, including 2 volts to run the heaters on the tubes. Well, now all the tubes have been changed to 6 volt tubes. So you just need to put 6 volts in where the 2 volts used to go. My guess that's exactly what was done here. So this is the transformer that's doing the job. And on it, it says right on it, 6.3 volts. 2 amps center tapped. I mean 6.3 to the center tap for a total of 12.6, or primary 115 volts. Okay, well, yeah, exactly. I don't know, there is a center tap here. Well, if they're powering these tubes with 12 volts, we would have known by now. So one way or another, he's got 6 volts coming in, these 2 green wires. One ties to this terminal, goes right to the chassis here. The other one, oddly enough, and this is something I spotted just before I turned the cameras on, so you could watch too. Where's the other green wire going from the transformer? It's going to this terminal. This terminal is exposed on the back. Oh, there's a jumper in here. I wondered about this jumper. So there's a resistor or capacitor right here, but with the jumper in place, this is just jumped out. It's shorted out. So this green wire is attached to the red wire, and then the red wire continues on through the radio. You can see it kind of working its way through the radio, feeding tubes. What about these guys? So here, so the feed comes right here. These as would yeah, I haven't drank any coffee yet. Okay, wouldn't be surprised, zing, to find out that the same wire was used all the way through the radio to tie together all the heaters. And sure enough, it has the same look all the way through the radio. Okay, so that's what he's done. He's brought this in, tied them here, got a short over here. If you take the short out, I mean, why would he even do that? Use these terminals and have to have a short applied. If you take the short out, you've got this thing, which I think is a capacitor. That would be the end of the heaters. They wouldn't operate. You got me. Well, I guess if you open up the jumper, you've got, no, that's stupid. I was going to say you've got 6 volts, but you don't really. Well, who knows? I mean, I don't know what was going through the fella's head when he was working on this, what kinds of maybe half-baked ideas he had, which in the course of putting the radio together into the state it's in, he fully baked those ideas, but remnants of the half-bakerage can be still in the radio. Who knows? And I'm not even sure you followed what I meant by all that, but that's kind of a half-baked statement coming from me. Okay, so heater's done in a not surprising way. Probably the high voltage done exactly the same. He just figured out, where the batteries went and just hooked up the output from his little circuit here. Okay. What else is there? Oh yes, that's this. Where the battery was. Now, there was a battery in here, soldered in here. And what I've done is I've just shorted this area out. That's probably not terribly helpful to the radio. Maybe at low volume it may not matter, or a little bit of volume and you may start hearing distortion, or maybe it was distorted the whole time, or maybe it's really wrecking the output of this thing and I don't even realize it. So I could stick a battery in there temporarily, back in there, and we could also put a battery in and then put a short in and see what the difference is. We could do these things. I just think there were 3 things that I wanted to. I wrote a list. Battery on schematic. Oh yes, the local oscillator for short wave. Now when I tried the short wave in this radio, I got nothing. And I didn't know why. I don't know why. One possibility is the local oscillator is not oscillating. And that would give the radio the characteristics that it was exhibiting. Seemed to be ready to receive, but received nothing at all. What is this for? What is this for? Oh, this was to hold this up. Right, I had this clip leading here holding this up. Local oscillator. I think that's a more interesting one to go at. And also I want to play the radio gain on AM. When I did it the first time, I had the band switch in the wrong place. Spent a fair bit of time with that sort of nonsense arrangement. Didn't spend a lot of time with the proper arrangement. So we're gonna feed some signals in here, and the yeah. Let me get my SDR and everything all set up here. I think I have some coffee to drink now, which might be good. Okay, you can see the SDR display, obviously. Now, that is responding to this coil here. Coil is just laying on my bench. The oscillator coils are right here. This is going to be good enough to pick up the local oscillator. We're going to operate the radio on broadcast. No antenna, signal generator not connected. We should still see the local oscillator, so just about ready here. I think so. Okay, here we go. So we're looking for a new signal to pop up on here. Oh, pop up is right. Wow, that was a pretty good prediction. You see how powerful it is compared to the other noise signals, all being picked up by this coil here. If I move the coil away from the radio, I'm sure the local oscillator will disappear. Bring it back. There's a bit of a delay in the SDR, about not quite a second or so. So things don't happen quite the way you would expect them to. Okay, is that really a local oscillator? Sure it is. If I tune the radio, it's moving around. That's a pretty strong signal. Something just made this go really loose. What happened? Okay, so we'll just have to tune the radio by turning the wheel. Okay, question is there a local oscillator on short wave? So we're going to flip to the, and also this proves, this is the broadcast band. Oh! Wow! Wait a minute. Wait a minute. This shouldn't happen. On the SDR, when you see the signal, when I tune, you see the signal level drops down and then reappears when I stop. That's an SDR effect. That's the SDR processing effect. That signal is actually not dropping down and showing up again. It's just moving across. Well, no wonder I got confused about which band is the broadcast band. It's got two broadcast bands in it. Let's go even further. We'll go all the way to good show. Phono doesn't show any local oscillator. Good. Well, this is kind of weird. Once again, I don't know which band is which. Let's go look for it in the shortwave band. So I'll set. So the pointer is right around. It's around 7,500 kilohertz on the shortwave band. So 7,500. So about 8,000. Somewhere around 8 megahertz. We should see. We should see the local oscillator. I'm having trouble finishing a sentence today. Okay, so we're now looking on here all the way from 7 megahertz up to 9 megahertz on this screen. I have nothing there now. Yes, there is something there. Tune the radio, see if it moves. Yes, it does. I'm tuning the radio down in frequency. It is going up. So that is not the local oscillator. That is an artifact possibly of overloading the SDR, but it also could be a product coming from the converter tube. I don't really know. I see these things all the time and really can't nail down what they are. Pretty well disappeared there, didn't it? You can hear some clicking in the radio. Well, maybe go slower. Don't know what to say about that. Why it disappears. But so if that's not the real local oscillator, where is the local oscillator? I can hear the radio now. That's kind of interesting. Cannot hear it there. Oh, it's just jumping just like it was on broadcast. Let's take the SDR down, 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 and see if we see more of these signals. We'll go down. 2 megahertz. You have to tune the radio a bit to identify any signal. Yeah, there's something there moving. Nothing strong though. We're down around 4 megahertz in the middle there. Okay, nothing moving. Makes you wonder what those. Makes me wonder what these signals are. What is this? And what is this? Are they from the radio at all? I'll cut their power to the radio. No, they're coming from who knows where. From who knows whereville. Go down a couple thousand more. Getting down into where there's huge amounts of noise. Tune the radio a bit. Anything in there moving. Oh yes, there is. So you can see a couple things moving. On the left is a huge signal. On the right is another one moving back and forth, going in the right direction. This is supposedly on shortwave, and this is supposedly broadcast. It could be, even when I have it set to shortwave, even though there is a signal at this frequency, this crazy signal here, which would be causing conversions to take place in the converter tube, other elements of the radio have been switched with this switch, expecting shortwave operation. And so some coils have been switched in somewhere, something's gone on, so that the result of this local oscillator and the signals it's converting can't be heard. I don't know. I'm trying to understand this as best I can. Another possibility is that I was thinking about this last night while I was going to sleep. There's a possibility the guy who did this to this radio got the radio to work on broadcast and then said, I can't get it to work on shortwave. Who cares anyway? Nobody listens to shortwave. Who cares about that? Broadcast, that's where it's at. Today it's not where it's at anymore, but back then it was. So he may have made this radio work on broadcast, on a broadcast band, and forsaked the shortwave band. And that might explain why we get two local oscillators to pick from at broadcast frequency. Because he may have done wiring things back here. Well, there are wiring things that were done back here, but did they cause this result? Wow, this is a tough one to figure out what to do about this. Other than do what he did, forsake the short wave, focus on the AM side of the radio. Okay, let's do that for now. I'm doing a lot of work here just to get the puzzle parts out, so we can look at the puzzle and figure out how it fits together. I think there's more parts to the puzzle. I haven't got them all yet. So the battery that was in here. So this is the shorting lead that I installed to short across where the battery was. And my thinking for doing that was, well, the audio signal is actually going through the battery, picking up, I shouldn't say it this way, but I will, picking up the voltage for biasing the tube and then carrying on, the signal carrying on. So with the battery out, the signal can't get through. This was my thinking. This is the way I've seen it in other radios. So I applied a short. Okay, I didn't even touch the radio there. So I applied a short to make sure the signal could get through and forsake the bias. But now I'm not so sure that's really the correct thing to have done, because one side of that battery is connected to the chassis, or was connected to the chassis. So this clip lead is connected. Well, this end of the clip lead would have been connected to the chassis if it were a battery. If this were a battery, this end is connected to the chassis. Okay, that's really odd that there's no scratchy noises or anything. Doesn't make any difference to the radio. At least the noise we're listening to. Let's listen to a better noise. I have no antenna on it. Well, what's the battery in there for? Okay, so I got my signal generator going. Let's hook it up. I have no other grounds on the radio. I'll put this on the antenna. We're tuned to around, let's tune to around 7. Why 7? No, just because I saw it. 7. Pretty strong signal. Okay, let's look at the local oscillator frequency. If we're tuned around 7, the oscillator should be around 11. So this is it here. 1155. So if we look at it exactly, we take this exactly. That's exactly 1150. And if we assume this is set to 455. So if we take 1155, take off 455, that's the same thing as subtracting 300 from 1700. So we're tuned to 700, we're tuned to 700. I still have a totally wrong frequency up here. I'm way off. What was I thinking? Here we go, 700. Well, there it is. Let me check the calibration here. It's way off. So I'm feeding a very strong signal into the antenna terminals that should be blasting out the speaker at any volume setting. How about... You can hear the garbly interference. This should be a nice pure tone. It certainly isn't. This does nothing. Maybe this connection didn't make here. Ooh. Oh! Tell you what we've got here. I think so that I went because the tone cleared up. There's so much corrosion in here from the battery. What I was going to say doesn't make any sense. This doesn't make any sense. This is connected to nothing. Why would it matter what I do to it? With this wire connected. Stick. What's happening there? So there's a big old capacitor here. Oh! Huh. Have a look at this. Have a look at this. What's happened to that capacitor? It's not obvious in the camera, but it is crushed. It has been. What happened to it? Maybe I get a little more light on it, we can see better. Okay, let's try that. Oh my gosh. What happened? Like, it's been speared. Something wet. Well, okay, I think we know the first capacitor we're going to change. We're going to get rid of this one right here. What happened to it? Kind of an odd thing. Well, I've got the close-up camera again here. This is the corrosion that I was talking about coming from the battery terminals here. And That's a remnant wire down there that I cut away from the battery that was soldered in. Well, once again, the stick has done the trick. Some other old. Look at that connection, that red wire. That's not normal. That's not how those connections are made. Oh boy, oh boy. Okay, first capacitor to change out. Okay, just noticed something off camera here that's worth seeing. So I have this on full blast. I'm going to turn it down by a factor of 10 and listen to what the radio does. Oh, it gets louder when you turn down the input signal. I suppose that could be nothing more than the AVC operating. Okay. Change out that capacitor, and we'll see what the radio does after that. You know, it's amazing. What you know, you're busily looking over here for something you suspect over here, and then while you're looking over here, hey, look at that. That's a problem. How many things in life work that way? Okay, let's cut that capacitor out of there. Now, because I don't have a schematic, I really, don't, offhand have any clue what this capacitor is doing in the radio. The other terminal looks like it's going to a ground. Very awkward to see in there. Yes, it's going to the ground terminal on the chassis. There it is. How does it get into this condition? Let's take a little bit of a closer look here. And what would happen to it that would cause this? Also need to know what the size is of this. This one's been in there a long time. Aerovox. That says 200 volts, and I think the rating is right where the schmozzle is. Well, I can't let this fun go by. Oh, it's just like mash. It doesn't feel like paper at all. What has happened? Has this been cooked? Is this what cooking does to it? Well, I've never seen one quite like this. Look at this thing. It's mashed potatoes in here. So what I'm peeling off here is the outer paper shell, which is usually quite rigid and certainly can't just be dug into like this. This is really quite odd. Oh, the whole thing is like this. Somebody gets spilled on it. you know, what happens in a radio? The only thing that happens in a radio is these things can get warm. I think if it got warm enough to cook it like this, then we would see lots of evidence. Now the other side is not nearly as. The other side seems more normal here. It feels and looks more like paper. I'm going to get a chance to see how they constructed it. And destructing it. Oh, okay, so there's the end. Doesn't look so good inside. You know what? That's two pieces of tin foil or aluminum foil or whatever foil, separated by paper, and then it's rolled up like a cigarette. Not really like a cigarette. No, that's not a good comparison. Rolled up like a yes, you know, this is really tough here. This paper is fairly well intact. Well, I'm not going to read the value. That's gone. You know, a capacitor of this size is going to be 0.05 anyway. Maybe even a 0.1, but I'm never going to read it off of here. So I'm peeling this apart for no reason now, except I haven't peeled it apart, so I'm going to stop because we're not going to get anything. What's the green? Green, why is it green? It's just a tape or something that they used during the making of it. Really gives you an idea just how clumsy these things really are. Like when you look at that, what is that exactly? That looks like a piece of wire coiled around, and it's trying to the way they do these. They have the two sheets of tin that are on top of each other, separated by a piece of paper, thin paper. I could almost peel this open at this point. Here we go. So it's so thin, I've torn through a couple layers already. And the way they do this is the one sheet sticks out this way, the other sheet sticks out that way, and the paper's in between. So on one end you've got one sheet sticking out, and the other end you've got the other sheet sticking out. Then all you got to do is just bump your connection up against the end. You can kind of see what, you know, bump the connection up good and tight, and then somehow stick that all together. So you can see how easy it would be for the separation to occur like it has here. I have unpeeled these in the past. It's stunning just how long the piece inside here really is. I'm not going to do it with this one, but there's the actual capacitor there. There he is. I don't think we'll be testing this one either. I think it's a little late for that. It's something I could have done had I thought of it. What a dummy, I didn't do it. I should have done that right away, but we kind of tested it in the radio. Final resting place. Okay, so my guess, 0.05. What's it doing? I don't know. I'm not going to figure that out. We're just going to replace it. Where did it come from? Did it come from here? Did it come from here? Yeah, that's the way it goes. I didn't put the clip lead. I can't remember. Coffee. Let's go for coffee. Okay, I'm going to solder in the new part. Now there's so much corrosion from the battery that was in here. I decided to connect this capacitor up here rather than on the terminal, directly on the terminal. because there was so much corrosion on the terminal. This too, where I am right now soldering, this was pretty heavily loaded with copper corrosion. I just brushed it off because it's very superficial here. There we go. Okay, now that brings us right into the proximity of another bad looking capacitor right here, but I've left it in for now because I really don't want to be doing too much at once. Every change you do can have consequences, unexpected consequences. So better to make a few changes and then deal with any consequences. Now, down here on my bench is the actual battery thing. Let's take a closer look at how they construct it. It's very simple, but at a glance you might not have realized what they're doing. So you have the lead wires coming in, and they pass through the porcelain, the white porcelain, to reach a contact point inside here, and the battery is stuck inside. And then that's spring loaded with this piece up here. This piece is not electrical, this is just to spring this stuff together, spring it together. And exactly what the blue is, it's a salt of copper. Could be copper chloride, could be copper sulfate, could be copper, I don't know what else copper can make. Copper oxide is brown though, so it's not copper oxide. Copper oxide is conductive also. It adheres tightly to copper, which is why copper is such a wonderful material. Basically, when you corrode copper, you get a new material whose volume is about the same as the copper it came from. Steel is very different. Steel, when you corrode steel, the new material, rust, is about 7 times the volume of the original steel. And that's why rust piles up on top of steel. And that's also why steel keeps rusting, because the rust doesn't seal it off. There are a lot of other metals, when they rust, they form a very, very tight, adherent surface, like this one here. Why isn't this metal rusting in some way? Because it has literally a coating, its own corrosion coating. That's the secret of stainless steel, aluminum, and other metals, even zinc. Zinc produces a coating. Aluminum, if you brush up aluminum, you see it's all nice and shiny because the electron cloud is at the surface. You just give it a few minutes and aluminum oxide will form and the shininess will start to go away, and aluminum oxide is not conductive, which is why aluminum is a bad metal to use for wiring. If you have it in your house, you should be checking all of your connections, all of your outlets periodically to make sure that they remain tight and aren't overheating, especially in these cyclic loads. The worst one being your refrigerator, which goes on and off all day long, day after day, week after week, heating up and cooling down the connections where the fridge is plugged into the wall. And if everything is good, the heating up and cooling down is so minor it doesn't matter. That's great. But if there's anything going on, that heating up and cooling down, expansion and contraction, will work whatever is going on into a worse state. And if the screw is backing out, and I've had this happen, that's what I'm talking about. I had this happen in a house I lived in. The screw backed out in the outlet that had my fridge plugged into it. And the thing got so loose, it was sparky. Sparky fire. Oh, danger. Yeah. I could tell you about it, but I won't. But that house almost burned down because of another electrical fault. We're just lucky we were home at the time. But I won't go into that one. So we have the capacitor in. Let's see if we solve the problem. Because you know what? It's an assumption still. It could be that I was knocking around something else that was making all that come and go-edness. Okay, so we still have the signal generator running. We have a ground on the chassis. Otherwise, nothing else is connected to the radio. We're ready to go. Power on. And it's warming up. I've put in a 160 volt capacitor there on the assumption that it's not going to be subjected to anything like that, but let's just check, because how come we don't hear a thing? Okay, so we're checking for voltage here. Too many things in my hand at once. I told my wife, and I follow this as religiously as I can, don't come down the stairs with both your hands full. You know, okay, sometimes you got it, but if you can avoid it, always have one hand free, so you can slap yourself after you fall. Okay. Voltage. What is across this capacitor? Is it on the verge of exploding? Well, that's less than I expected. To be honest with you, I didn't expect a 0. Is my meter working? Have I got this correct? Let's find another voltage to read. I'm on the 600 volt scale, so we can go anywhere. We can go anywhere, touch anything. I want to touch something I think has a high voltage on it. Something else that might have a... Oh, we're on the power supply here. There we are, 156. No, so once again checking this capacitor. 0 is a little odd. Yeah, we just expect to see some little voltage there, but maybe not. Okay, but the capacitor's not going to blow up. Now, is the radio actually working? What do we got going here? Okay, so I'm... Doesn't sound particularly better, does it? Now I am feeding it with the signal generator signal. Let me do this the easy way. It's easier to tune the signal generator than to tune the radio. Hello. Oh, way down. Okay, so it's 680, and you can see on the dial 680. Now, if we flip to this shortwave sort of AM alternate setting, we can move the local oscillator slightly because we saw that earlier. So the radio's tuned slightly different. Can we find it with the signal generator now? And I don't think so. Okay, gonna give it heavy juice. Heavy juice. Nothing, of course. Okay, so I think it's really proving now that that is a broadcast band. I just can't imagine that's not right. Tune this guy back. Okay, it still has that warbly sound to it. It's not a pure tone. A little more juice. That may go away as I continue with a couple more capacitors in here. But I am worried that that is really coming from the AC supply to the tube heaters. I don't know that to be the case, but... Okay, and we're going to call it quits here today. That's enough. I got enough stuff. I feel like I'm getting in control. Obviously I have enough nerve now to make some changes to the radio. I will have to just replace parts basically like for like, because I don't have a schematic to analyze. For all I know, the fellow who worked on this made a lot of dramatic changes to it that are not apparent. Like all these wires look weird in here. They don't look the way they would look from a factory. So no. Well, it looked to me, did it look like the shortwave local oscillator was in existence there? I'm not going to worry about it. I'm not going to worry about that right now. Concentrate on making the radio work on the AM band to start with, and then do shortwave next. I think that's probably the best strategy there. So, okay. Thanks a lot for watching. I hope you enjoy your day. It's cloudy here, cool today. Rain is coming, and that's a good thing. Heavy rain coming tomorrow, I think. And that's a good thing because it's very dry around this area here. And very dry throughout much of Canada and Ontario. Okay. Thanks a lot for watching, and see you in the next video.